Hi everyone, welcome to Day 8, Section 7.6, Rational Exponents. So today we are going to write expressions with rational exponents in radical form and exponential form. And then we're going to be simplifying these expressions. Alright, so before we can begin, we have to talk about exponential form versus radical form. Alright, so exponential form is going to look like the following: a to the m divided by n. Alright, so this is our exponential form. The only difference that we're dealing with now is that our exponents are rational. They're fractions, okay? They're ratios. So n is going to represent the index when we change it to radical form, okay? And m simply represents the power when we change it to radical form. Alright, so when we change this to radical form, like I said, it's going to look like the following: the nth root of a to the m power. Okay, another way we could write this is the following. We can use parentheses and say the nth root of a all raised to the m power. Okay, so you need to be comfortable going back and forth from one form to the other. So if you have any questions after we go through the next few examples, make sure you ask those in class tomorrow. Alright, so let's go ahead and convert. Let's look at this first example here. Alright, we're going to convert from radical to exponential form. Okay, so look up above at the radical form. Okay, we have the fifth root of x squared. Remember, our base stays the same as the radicand, so x. Okay, the power, that 2, is the numerator of our exponential power here, divided by our index, which is 5. So we get x to the 2/5 power. Okay? Go ahead and try part B on your own. Rewrite the 7th root of m cubed in exponential form. Okay, hopefully you were able to do that, and you should have gotten m to the 3/7. Alright, so hopefully you got those two, and you're understanding how to go from exponential to from radical form to exponential. Now we're going to do the reverse. In example 2, we are going to convert from exponential to radical form. Alright, so same rules apply in terms of where the index is located. Alright, so for this first one, 7 to the 1/4 power. The denominator of that power is our index. So we have the 4th root of 7 to the 1st power. Okay, now since it's to the 1st power, we don't necessarily need to write that 1 in there, but we certainly can. Alright, so go ahead and try part B on your own, rewriting it in radical notation. Okay, hopefully you were able to do that, and you should have gotten, again, our index is 2, so we have the square root of k to the 7th power. Now notice I didn't write my index in there, because remember, our index, if it's not written in, it's 2. Okay, so I could have written a 2 in there, but it's not necessary. Okay, you typically won't see it written that way. It's implied that it's there if it's not written. Okay, so again, like I said, hopefully you feel comfortable going from one form to the other. That's very important from here on out. Let's continue on and now evaluate these expressions with rational exponents. Okay, so now we're going to essentially simplify, evaluate, get a number that these represent. Okay, so let's do some zooming in here. So the first one we are going to look at is 25 to the 3/2 power. Now, when I go about evaluating these types of problems, I like to convert to radical form. All right, so this is really telling us to first take the square root of 25. And after we do that, we then raise it to the 3rd power. Okay, so this is where your powers really come into play. You need to know your perfect powers. Okay, so what is the square root of 25? Well, the square root of 25 is 5. And now we are going to raise that to the 3rd power. And 5 cubed is simply 125. Okay, so 25 to the 3/2 power is 125. All right. Let's look over on example B, where we're going to do something very similar. Okay, so we've got 64 to the negative 2/3 power. So the first thing I like to do is convert to radical notation. So we want the cubed root, because our index is 3, of 64. And after we take that, we are then going to raise it to the negative 2 power. Okay, so we evaluate the inside first, inside of our parentheses. The cubed root of 64 is 4. And we're going to raise that to the negative 2. Well, our exponential properties stay the same, no negative exponents. So this 4 is not happy where it's at. It's going to be happy in the denominator. So this is really 1 over 4 squared, which we then get is 1 over 4 squared is 16. So we get 1 over 16 as our final answer. So 64 to the negative 2/3 power is 1 over 16. Okay, so let's try this last example on this page. Evaluate 1 over 81 to the 3/4 power. Again, rewrite it in radical notation. So this is saying the 4th root of 1 over 81. So after I take the 4th root, we are then going to raise it to the 3rd power. Okay, well, just a real quick reminder, the 4th root of 1 over 81 is the same as saying the 4th root of 1 over the 4th root of 81. And then we can evaluate this. Well, the 4th root of 1 is simply 1, and the 4th root of 81 is 3. And then we're going to raise this to the 3rd power. Well, 1 to the 3rd power is 1, and 3 to the 3rd power is 27. Okay, so we talked about converting from one form to the next and then evaluating. I like to change it to radical notation to really take care of that index, that root first, and then raise it to a power. Okay, let's move on to the next page and continue with our notes. All right, so now we're going to be simplifying the expressions using the properties of exponents. So it's the same properties as before. Okay, so let's make a little note. Okay, same exponential properties that we talked about a few chapters ago. Okay, so if we take a look at our first example, 5 to the 1/3 times 5 to the 3/4. Well, let's zoom in a little bit. Okay, when our bases are the same, 5 and 5, what do we do to the exponents? Well, we add them. Okay, so it's really 5 to the 1/3 plus 3/4. Well, the only difference now is we've got fractions to add. So in order to add fractions, we need common denominators. So what's the common denominator between 3 and 4? It's going to be 12. So we can do a little side note. Instead of 1/3, we're going to have 4/12 plus, instead of 3/4, we're going to have 9/12. So when we add these together, we're going to get 13/12. So our final answer is really 5 to the 13 over 12. Okay, so it's those same properties that we've already talked about. The only difference is now we're dealing with fractions. Okay, so let's take a look at this next example here. Example B. Okay, so in example B, we have x to the 3/8 raised to the 4th power. This is a power of a power. So what did we do before? We multiplied. So we really get x to the 3/8 times 4. Okay, multiplying numerator times numerator, denominator times denominator. Well, this is like saying 4 over 1. So we get x to the 3 times 4 is 12. 8 times 1 is 8. And the last thing we have to do is simplify our ratio, our fraction, our exponent here, and 12 over 8 simply goes to x to the 3/2 power. All right, and there we have it. So again, the properties remain the same. Okay, we're just dealing with fractions now. So let's take a look at example C. 7 divided by 7 to the 1/3 power. Again, when bases are the same and we're dividing, what do we do to the exponents? Well, we subtract them. So this is really 7 to the 1, because we really have a power of 1 up in the numerator, minus 1/3. We can do our side note. We need common denominators, so that's like saying 3 over 3 minus 1 over 3, and that's going to get us 2 over 3. So we really have 7 to the 2/3 power, and we can just leave it just like that. Okay? All right, let's keep chugging along here. So let's take a look at example D. All right, what we should notice about example D, we have 18 to the 1/4 divided by 9 to the 1/4, all raised to the 3rd power. Well, we can't combine these yet. We don't have common bases here. We have an 18 and a 9. But what we should notice is that both of these are being raised to the same power here. So we can rewrite it a little bit differently. All right? So the first thing I'm going to do is combine and say, well, this is like saying 18 divided by 9, all raised to the 1/4. And then this whole thing is still being raised to the 3rd power. Okay? So when we do that, what we should notice is we can now simplify 18 over 9. And when we simplify 18 over 9, we are going to get 2. We are going to get 2, sorry about that, to the 1/4, still all raised to the 3rd power. Okay, and now we just take a look at what we have left. we have a power of a power situation, so we multiply the powers together, and we're going to get 2 to the 1/4 times 3 is simply 3/4. So 2 to the 3/4 power. Okay? All right, so hopefully we recognize and remember our exponential properties. And now we're just dealing with fractions. Okay, the last thing we're going to deal with today is example 5. We are now going to be simplifying radicals. So before we were dealing with exponential form, now we're dealing with radical form again. Okay, now the key with radicals is in order to combine them in any way, they need the same index. Okay, when we're multiplying and dividing, they need the same index. So a little side note here is if they have different indexes, all right, different indexes tells us that we need to convert to the other form. Okay, so if we're in radical notation and they have different indexes, we have to convert to exponential form. Okay, so let's take a look at this first example here, example A. All right, and if we zoom in a little bit, might make things a little easier. So here we go. We have the square root of 10 times the 4th root of 10. Well, the square root of 10, our index is 2. The 4th root of 10, our index is 4. These do not match. Therefore, this first step we're going to do is rewrite this in exponential form. Okay? So instead of the square root of 10, we have 10 to the 1 over 2. Remember, the denominator of that power is the index. Okay? Times 10 to the 1 over 4. Okay, now we're using our exponential properties. When our bases are the same and we are multiplying, what do we do to the exponents? We add them. So we get 10 to the 1/2 plus 1/4. And now, since we're adding fractions, we need common denominators. So instead of 1/2, to get the common denominator, we will have 2/4 plus 1/4 is going to give us 3/4. So we really have an answer of 10 to the 3/4 power. Okay? Now, typically, when we start in radical notation, we write our answer in radical notation. So let's just go ahead and convert this back to radical notation because that's most likely how you will see it. Okay, so 10 to the 3/4 power is going to be the 4th root of 10 to the 3rd power. Okay, and we could really technically simplify 10 to the 3rd power even further. We could call this the 4th root of 10 to the 3rd power is 1,000. Okay, so technically all of these are acceptable, but you'll most likely see answers in radical notation if we begin in radical notation. Okay, so let's move on. We're getting down to the wire here. The square root of x over the cubed root of x. Again, we have different indexes, so we have to convert to exponential form. So instead of the square root of x, we have x to the 1/2 power. Instead of the cubed root of x, we have x to the 1/3 power. Okay, and now that we're dividing and we have common bases, we can subtract the exponents. So we get x to the 1/2 minus 1/3. Okay, and our little side note, we need common denominators. Common denominator is going to be 6. So instead of 1/2, we have 3/6 minus, instead of 1/3, we have 2/6 for a grand total of 1/6. So we get x to the 1/6 power, or remembering if we convert this back to radical notation, we would get the 6th root of x to the first power, or simply the 6th root of x. Okay, so there's our answers there. Okay? All right, last one. Here we go. Example C. What do we notice right away? What's different about example C? Well, we've got the 5th root of 2 times the 5th root of 64, all divided by the 5th root of 4. So the index is all the same. No need to convert. Let's rewrite it as one big radical. Okay? So we can combine all of this. So this is like saying the 5th root of 2 times 64 all divided by 4. And when we simplify that, okay, we get the 5th root of, well, 2 times 64 divided by 4 should get us 32. And everybody should know what the 5th root of 32 is by now, knowing our perfect powers, knowing our 5th roots. The 5th root of 32 is 2. All right? Okay, so again, a lot of practice problems here. Okay, the key is being comfortable going from one form to the next. All right, if you have any questions, come on to class tomorrow with them. Have a good night. Bye.